Here we go, 8-8. How do we determine which equation to apply when compounding? Compounding is key here, okay? And it really depends on how often you are compounding. So if it's compounding once per period, all right, that's your typical growth decay problems that you're used to. So growth slash decay. And what you really need to know is that it is once per period, okay? The period doesn't have to be annually. It could be once every month, but most often, okay? So most often we're dealing with annually. So the next one is compounded n times per period, which is just what it sounds like. It can be compounded maybe 4 times in a year, but it's usually n times a year, but it can be some nastier problems where it's, you know, 3 times in an hour or 4 times in a month, and you have to be careful with that, what the period is. But it typically is going to be per year, okay? Formula is only slightly different. You're just dividing by n to the nt power. And again, it could be n times a year, or it could be n times in a month. The key here is to understand year versus month and so on and so forth. So if it's per year, it's easier to use n times per month, you know, 12 months in a year. Daily it's 365, weekly 52. You might want to write down that quarterly means 4. That's not a bad idea too. And then the last one is compounded continuously, and that is where it's just always compounding, and the E is the portion here that shows up. So whenever we see E, if you see that E, all right, or you see the word continuously, it means E. Okay, and that's what you need to think about. Continuously is always E. It's infinitely small amounts of time. It's continuously being added small amounts over and over and over again. You get more money that way if it's compounded continuously, which is why banks don't do that. So, I don't know what's going on. I'm going to pause it. Things that you must know or should know. All right, these are must memorize equations. You have to know them. You have to know when to use each one. I'm not going to be giving them to you. A is the amount in the account. That's the amount in the account after a given amount of time. P is the principal, which is the initial amount. That's extremely important that you understand that. R is the rate, but it's expressed as a decimal, so you're going to see them give you a percentage rate every single time, and you're going to know I got to divide by 100 to make that rate a decimal. N is the number of times it's compounded, and T is the amount of time. And it doesn't always have to be years. It can be months, days, minutes, hours, weeks, seconds, so on and so forth. Okay, so let's jump into actually doing some work here. I spent 10 minutes trying to figure out how to get this thing to work right. You invest $100,000 in an account with 2.2% interest per year. Assume you don't touch the money or add money other than the earned interest. Write an equation that models the situation. So right away you have to ask yourself, is this once per period, n times per period, or am I compounding continuously? So you're putting the money in. This is our once per period type of question. We are just dumping that money in. It is only adding it 1 time per year. It's 2.2 interest per year. Okay, it's not saying it's doing it multiple times per year, just the once. So 2.2% interest per year. So we're going to pick our equation, the very first one. A equals P, which is the principal amount, 1 plus the rate to the power T. So A equals the principal, which is 100,000. And we all wish we had that. 1 plus, we have to change this decimal, or to a decimal I should say, the percent to a decimal. So 1 plus 0.022 to the power T, and there is my equation. Now oftentimes it's written as in function notation, so it's A of T equals 100,000, 1 plus 0.022 to the power T. Oh, again, what a waste of my time. Okay, here we go again. How long will it take for your investments to grow to 125,000 to the nearest hundredth? So, investment needs to grow. You want 125,000 as your final amount, and that's the part that you need to catch. This amount right here is your final amount. That's your A value, or your A of T. So I want to have 125,000 equals the 100,000, and then we have the 1.022. I don't know why I didn't change up above, but I totally should have. 1.022. That's what I should have had there, to the power t. And we're going to work backwards and solve. Just give me a second. So, to solve this type of problem, you're going to first divide by 100,000. Okay, question that we've solved before. So I get is 1.25 equaling 1.022 to the power t. We're going to change it from ben to log, from exponential to logarithmic form, so from ben to Benét. So this is log, come on, you can write, log base stays the base, 1.022 of our 1.25 equals t, the exponent. Log always equals the exponent. Okay? So from there, type in the calculator, get yourself an answer. T works out to be 10.25 years. So they can make this question a little bit nastier, and the Regents typically, well, it can, I shouldn't say it typically does, doesn't always, but it has in previous years, where instead of saying round it, whenever they say round it, you should be like very grateful, because when they say we're to round it, it's just okay, I'm going to round my answer and I'm done. But if it says during, which year did it happen? Well, it doesn't happen during the 10th year, right? Because from 0 to 1, where t is 1, is the first year. From t equals 1 to 2 is the second year. So from t equals, 10 to 10.99, right, or 11, is going to be the 11th year. So if this question were to say, during which year, instead of nearest hundredth, during which year would it finally reach 125,000, you would have to round this answer up to 11, and you do want to be careful about that. All right, moving on. Okay, example 2. So, again, you're investing $100,000 in an account with 2.2% interest, but now it's compounded quarterly per year. So compounded quarterly in a year. Assume you don't touch the money or add money other than the earned interest rate, an equation that models it. So now we're going to jump to the next equation. So A equals, or A of t equals, it is P, parentheses 1 plus R over N to the NT power. So A of t is going to equal the principal, which again is 100,000. It's supposed to be a 0. 1 plus our 0.022. This time we're going to divide that by how often we are compounding it. It said quarterly. Quarterly means 4 times in a year, so we're going to divide by 4. And we're also raising it to the NT power. So quarterly means, compounded quarterly means n is 4, so after the 4t power here. So that new equation is A of t equals 100,000. When you type that in the calculator, you get 1.0055 to the power 4t. Next question, how long will it take for your investment to grow to 125,000? Same idea, same problem. You start at 125,000. You're plugging it in and working backwards. So, divide by 100,000 again, get the 1.25. I'm going to kind of skip over that step because I don't have the room. And this problem has a little more work to it. Right? When I change it into logarithmic form, my base stays the base, 1.0055. The log always equals the exponent, so it's going to equal 4t. So it's log base 1.0055 of 1.25 equals 4t. From there, you type in your calculator, divide by 4, and you get t equals 10.17 years. And again, in this problem, if it said during which year, okay, is the account worth 125,000, you would say during the 11th year. If it said by the beginning of what year, okay, well, it wouldn't be by the beginning of the 10th year, right? It would have to be by the beginning of the 11th year, so you got to be careful. It could say during which year, or by the beginning of what year. Okay? All right. Moving on to example 3. So, again, you invest $100,000 Man, don't we wish we had $100,000. In an account with 2.2% interest. So again, here we go. But now it's compounded continuously. So you want to pay attention to that word, whether it's compounded at all or whether it's compounded, once per year, 4 times per year, or continuously. In this case, continuously is the key word there. So because of that, we're going to be using E. Assume you don't touch the money, write an equation that models it. So this is the A equals, or A of T equals, P e to the RT. So we're going to plug in A equals, the principal amount is again $100,000. E to the RT, 0.022 T. And again, we can write it in function notation if we want to. Or you can write it, it doesn't really matter which way we write it. That's fine. So how long will it take for your investment to grow to 125? Solving this one pretty much the same way. Okay. All right, so growing to 125, we're going to plug it in. So we have the 125 equals the 100. E to the 0.022t, divide by 100,000 gives us 1.25 equals E to the 0.022t. Now, when you have E, you can use natural log if you want to. For the benefit of this class, I think to make it easier, we're going to stick with just using regular log. So it is log, that was horrible, log base E. That's what we're going to write here, if I can get this to work. So log base E of the 1.25 equals 0.022t. Remember the log, when you're changing to log form, we're back and forth. The base always stays the base, so this is the base, and a log always equals the exponent. Okay. And there are other ways of doing it. I'm sure Ms. Griffin has shown you other ways too. That's just one that stuck for me. Base stays the base, switch to the 2. All right, anyways, type that in your calculator, and then divide by 0.022. You'll find the E button is the pi button. If you push pi on the calculator, then you'll see where E is, and you can type it in. So it works out that you get T equals 10.14 years. And again, if it said during which year, you would say during the 11th year. You'd be rounding it up. If it said by the beginning of which year, you'd also say by the 11th year. Okay, because it doesn't happen at the beginning of the 10th year, that's for sure. All right, which type of investment earned the most money over time? And that's the compounding continuously is going to. Obviously, it took less time for it to make the 125,000, so it's going to make more money. And when you're always adding, compounding and adding the money continuously to it, you're going to be making more money. So continuously compounding is the answer. And again, it's because you're constantly adding the money back onto it. Okay, you're getting more compounding when you're continuously doing it, as opposed to when you're doing it, what do we have, 4 times a year or once per year. Okay. All right, don't forget to write your summary and do your practice.